Okay, so our learning target today is I can graph transformations of functions. And so here's all the function notation rules for transformations. So they're using like f of x plus c. So the thing to just pay attention to is that plus c is on the outside of the function, minus c outside of the function. That's a shift up and down. Plus c inside and minus c inside, that's to the left or to the right, and it's the opposite of what you think. Okay, these ones are fairly new. This negative in front, that is a reflection over the x-axis. A negative inside is a reflection over the y-axis. Okay, I just remember it as opposite. Sitting directly next to the x, it's going to be a reflection over the opposite axis, the y-axis. Okay, and then we're also going to be talking about dilations. So a times my function is a vertical stretch by a factor of a if a is bigger than 1. A times my function is a shrink by a factor of a if a is between 0 and 1. The horizontal ones get a little funky because it's inside your function and you are shrinking by a factor of 1 over a, and I'll talk about that more in another video. So if I were to describe these transformations performed onto f of x, my parent function is f of x equals x squared onto g of x. So this is just function notation to describe it. So it's x minus 3 inside of the function, so that is to the right 3. The minus 5 is outside of my function, so that is down 5. Now this one we have both of them. We have inside my function, so that is left 1, and outside my function, so that is up 2. The negative here sitting outside of my function is a reflection over the y-axis. Okay. The 1/2 being multiplied in front, that is called a vertical shrink because it is less than 1. That number is less than 1. It's between 0 and 1 by a factor of 1/2. Here we have a negative 3, so the negative means it's a reflection across across the x-axis. And the 3 means it's a vertical stretch. Okay. By a factor of 3. Okay, so let's talk a little bit more about some of those. So here is an example over here where we have my parent function is in red, and we want to transform it to the blue. Okay, so what is happening? So I would have y equals, and we're going to do it on my function with function notation, and then we'll do it with our quadratic. So first of all, I notice that it's a reflection over the x, so we're going to put a negative on the outside. We're also shifting to the right. Looks like we're going to the right 4 right here. So to the right means we're going to do the opposite symbol. So to the right 4 means a left, or a negative symbol. And then we're going to go down 1. So that's the notation for function notation, but we know that's a quadratic. So the quadratic means we square. Our rule is to square it. So it's x minus 4 squared, and you still have the negative. Okay, so another thing I wanted to talk to you about was y equals negative square root of x versus y equals square root of negative x. And not every function reflects over the y very easily. Like a parabola, it's an even function, it's the same. So negative square root of x, so here's square root, here's my parent. A negative on the outside of the function is a reflection over the x-axis. So this is negative square root of x. A negative on the inside is over the y-axis. So over the y-axis would make this one look like that. Okay, so in the next video I'll talk more about dilations.